what we discussed in the previous section. RSA. If you remember, at first we should choose two large prime numbers, say P and Q. Then we must calculate the result of multiplication of these two big prime numbers, say n. So n is the product of P and Q. Okay. Then we define the totient of n, phi n. The totient, what's totient of n? Totient of n is a number of numbers that are coprime to the n. Okay, and there was a formula p minus 1 multiplied by q minus 1. This is the totient of n. And now we should choose E in a way that it must be a coprime of totient of n. E must be relatively prime with totient of n. So the pair n e is the public key. Okay, this is the public key. Now we can calculate the ciphertext for encryption using this formula. M is our message, m to the power e mod n. Okay, before that you should convert the message to into an integer. I don't know, for example, you can convert each character to its equivalent ASCII code, for example. You can search about how RSA converts messages to a number. Okay, so using this formula we can encrypt message M. So C is the ciphertext. Okay, now what should we do for the decryption? For the decryption, at first we should choose D in a way that D multiplied by E must be equal 1 mod totient of n. And D is the private key. D is the private key. So now with the message using this formula, C to the power of D mod n. Okay, that was the RSA algorithm, choosing two large prime numbers P and Q, then calculating the product of them, say n, then finding totient of n using this formula, and choosing E, the one part of the public key, in a way that it must be coprime of totient of n. Okay, so n, the pair of n e is the public key. Using this formula we can encrypt a message. Then we should define our private key using this formula. In fact, we must find D in a way that this formula must be satisfied. And finally, using this formula, we can decrypt our message. Ciphertext to the power d modulo n. Okay. Please, if there is any question, let me know. Otherwise, now I want to show you how use the associated libraries in Python. In fact, how in Python we can generate public keys, private keys, how we can encrypt the message, how we can decrypt the message. No question? Okay, good. Just a moment, please. For starting Python programming, there are many online calculators for RSS. In fact, actually use it. Here, choose the size of the keys in bit, for example, 2048 bit, the size of the keys. Then, using this button, we generate the this is the public key. Okay, and I want to message. This is my message. For instance, copy public key here. This message. This is the public key and my RS and encrypt now. This is the encrypted text in base 64 format. And message here. Decryption, we should use the private key. So the private key here, I choose A and the hello. Just I want to say there are many ways for using. There are many online sites. Now I want to use libraries in Python for programming, encryption, decryption, and digital signature. Okay. Here we go. Can you see this page? The Jupyter. This is Jupyter. Okay. For using RSA libraries in Python, at first we need to import these libraries. In this course, we will work with the cryptography library. Okay, so from cryptography Hazmat backends. This is RSA library. Okay, from cryptography Hazmat primitives asymmetric. Import RSA. This is the main library. We need it. And to import serialization. Before starting, let me explain what is serialization. Who knows what is object serialization? Object serialization. we need them also in the exam, but I don't ask you to implement some programs. Just I will ask you to use these libraries, okay? For example, I will ask all of you to create, with today's programs, I will give you some programs today. I will ask you to create public and private key. Then I will ask you to share the public key, but keep the private key safe, okay? Maybe in the exam, I send a message, an encrypted message to you with your public key and ask, okay, now send me what was the main text. In fact, decrypted message. You know, very small piece of programs. We don't need complicated programs. What's object serialization? Who knows? Nobody? Suppose that we have a class. For example, class student. As you know, each class has some attributes, which may be private or public, but we don't care it's private or public. Yes, exactly, Zainab. Yeah, your answer is completely right. Okay, suppose that each student has an ID, average. When I define an object, for example, say student X. Okay, X is a student. If I want to print X, X is just a variable and has an address in the memory. But if I want to print the content of this object, or I want to store the content of this object somewhere, I must serialize it. Serialization means converting the data associated with an object to series of bits, sequence of bits. Okay, this is called serialization, converting an object to a sequence of bits. In fact, only the data part, not the methods, not the functions, only the data part is converted to a sequence of. So suppose that I'm running a program now. I have many objects, but I want to stop the program. Before that, I can serialize the objects. I can store them in a. Then in another program, for example, tomorrow, again, I can open those files and read those objects from that file and continue the program from the point that yesterday was stopped. Okay, so let's back to the Jupyter. So we need just these three libraries. What I want to say in this lecture, I want to show public key, how to encrypt a message, how to decrypt the message, and how to create digital and digital. Okay. If you watch the previous video from previous lecture, I talked about encryption, what is digital signature. If we encrypt a message using public key encrypt. If we decrypt a message using private key, it's called decryption. But if we using key, it's called digital signature. Okay, encrypting using a signature. And let's see the program using this command RSA private key. You can simply create a private key, but it's an object. Please note, this private key is an object. You say generate. There are some parameters. Each value may result in a different private key. The key size, you can use 512 or 1024 or other larger or key size in bits. And the third parameter is backend. Okay, so just calling this function with these three parameters, you will have an object. This is private key. Now, to see what we should serialize it, we should convert it to a sequence of bits. To do so, I want to print out the private key. Okay, to do so, this is the object key dot private bytes. Using this command, I want to serialize the private key. I want to convert the private key to a printable format. In serialization encoding PEM, there are two formats for representing. Please note, there are two formats for representing private and public, PEM and DER. What's the difference? I will talk about that today. Format. So this private byte has three parameters. The first one is encoding. You can use either serialization encoding.pem or serialization.encoding.der. Okay, you can use two values. Then the second one is the format, traditional OpenSSL, and this is about encryption. You're saying that no encryption. In fact, you can put a password for your private key. Here, I don't do this. Okay, so here a private key, we do the password. Then to generate the public key, I use this command, private key.public key. So public key now is an object. I can save them in a file using this command. I create a file with the name, for example, RSA key.write binary, private key private by exactly this command which I used here to out the private key. Here I have saved the private key into the file named rsakey.pem. Then I have printed the public key using this command. Key, as I said, public key is an object. This command serialized this public key, encoding serialized encoding PEM, and the format is this. Here I have saved the public key into a file named rsapub.pem. If I run the program, the format is called. This is the private key. You can change some parts. For example, you can change the PM to DER, okay? DER, DER. See, it's the site is PEM is for the PM. So PM PM and yes, we're lying. Each private brand private key, all other private have the same private and public key, and this is why it's very long. Into file, you know, we don't copy and paste it. We usually save it into a file, and when we need, we use the file. So here I save them into the file. RSA key is my private key, and RSA pub.pm is my public key. Okay, so this piece of code, a private key and its associated public key. So I ask you to run this program on your computer. I ask you this piece of code on your computer. Keep safe the private key and share the public key into the, okay? Share your public key into the Telegram group. So I will send you some encrypted messages with those public key. Okay? Just run this piece of, save this file onto your computer because you need this file for decryption. And here this file, this piece of programs, yeah, you need this piece of programs for the exam. Okay. How find private key using RSA algorithm. Okay. Now this is the, I don't send you the program because this is the program. You just, if you search, you can find these piece of codes into the internet. Okay. Are available from the net. So you can simply just copy paste the program and run the program, or even you can write exactly these commands into your computer, run it, and key to the group. Okay. Now let's encrypting a message. We need these libraries, hashes. In the previous lectures, I have used hashes, load pin private key and load pin public key, because I load these two format of the private and public key. For DER, you should import DER private key and load public key. Okay. My plain text is something hello or I don't know, whatever you want, 2, 3, everything. This B converts this string to byte, so the plain text must be byte. Okay, to encrypt this message. Now, in the previous piece of code, I saved a file rs8pub.pem here. Here, public key, load pem public key. I read the public key from the file and store it to Alice public key. So Alice public key now is an object, is a public key. Now, for encryption, I use this key dot encrypt. So method encrypt from a public key object encrypts a message. The parameter, the first one is the plain text. I want to encrypt this message, in fact. Okay, so this is here. The second padding algorithm. This padding SHA-256. What's padding? You can search through the internet and you can read about padding. It's not important. I want just some encryption. Okay, now after executing this command, I have this ciphertext. This is ciphertext. This is the encrypted. This is the encrypted message for hello Wahid 123. So here I have printed out the ciphertext as a hex. So like this is printed. Okay. Then now I want to encrypt the message. For the encryption, I need the private key. So again, I open the file which contains my private key. I read my private key using this command, serialization load pem private key. So Alice private key now is the object of the private key. Using this command, Alice private key dot decrypt the parameter ciphertext, again the padding algorithm. I decrypt the message. So D now is the decrypted message. Here I have printed the encrypted message. This is the encrypted, this is the main message. If I run the program, this is the encrypted message, and this is the message. Everything you want, you can put here. Encrypted message. So using this piece of code, you can simply encrypt. There is no algorithm in this piece of code. I just calling the methods. You can change text for encryption, but for encrypting you must call this function, a public key encrypt. Okay, you can't. Oh yeah. Yes, you can change SHA-256, for example. Yeah, you can. But please note, if you do this, if you change this part, the encryption also you must change this part. Okay? So RSA, this is RSA, okay? RSA is using SHA-256, okay? Here, as you can see, for encryption, RSA needs a hash algorithm. Here, we are using SHA-6, but it can be another hash algorithm, okay? This what is this? This is the same as this is nothing. Here is exactly the same program, but using a password. Using a password, you can password for your private key. It's very important. If someone have access to your private key, so can encrypt all your messages. So it's very important. Keep very safe the private key. So you can define a password for your messages. Okay, now let me check. This is low. Okay. This part algorithm is the same before, but when I'm trying to save the private key, this part, I put password 1, 2, 3 in the previous encryption algorithm serialization dot no encryption. Okay, bytes, no encryption. But here, private key, private bytes, you can use encryption algorithm serialization best action. You can use your desired password. I put 1, 2, 3. So when you want load the key from a file, you should use this password here. When you load the private key, you must take the password as one of the parameters. Okay. And finally, our signature. What's a signature? Signature is used for authentication. In all cryptocurrencies, when you want to spend your money, you must sign your transaction. Suppose that wants to one. So Bob must create a transaction containing the address of sender, containing the address of receiver, and also Bob must put a digital this is Bob, and no other person can spend Bob's money. Next, about blockchain, transactions, blocks, and everything. Okay, but for now, some cuts that when we want to talk about blockchains, blocks, transactions, and blockchain. Creating a digital. Suppose that I have a message. I want to sign this message. How to sign this? I must use my or have my public key, so they can simply check it. If everything is okay, it means that sent me. So a signature is used for authentication. Okay. Message. Key. This is a private key object. This is a private key object. Alice private key. This is Alice here. Okay. I have private key here. So private object line generates a digital signature. This put the first one is the message. This is message. The message we want to sign. Then padding, and finally for this case, if I run the program, this is the signature. This is the digital signature. Please note, every time run, this will change. You know, maybe you say, oh, what happens? The message is the signature changing. In fact, digital signatures are used once. Digital signatures are used once. It's important that digital signatures can be verified. How? So here I have created digital signature. Now I want to verify piece of verification. Here signature. Let me copy, paste. Okay, so using this command, bytes from hex, I converted this hexadecimal string to its. Okay, so this signature but in the byte format. I have the main message, a message I want to sign exactly like this, and the object public key. Public key is signature, the message, padding, and hashes. Okay, I run the program. Okay, nothing happened. But if I change, just I want to change, for example, the first character to, for example, D, and now there's error, invalid signature. It means that this signature is not valid for this message. Or if I change now, everything is okay. If I, for example, change this message, for example, I put just a space at the end of it, just a space. Okay, if I run the invalid signature, about padding, these algorithms work on different sizes inputs. Okay, different sizes. Before converting or decrypting or encrypting the message, the input must be specific size. Padding means that putting something extra at the end of the message to resize the message to a specific size. There are different algorithms, and using different algorithms results different outputs. For example, if you encrypt a message with my program, with this program, you can't decrypt it with that websites, online websites. Or if you encrypt a message using the first website, you can decrypt it with the second website because these padding algorithms are different. You can search more about padding, but we don't need these details. We just use these concepts for technology. I will send you the program. Don't worry. Even though you can simply search the web and you can find these simple comments. So this is the digital signature. Do you know what's the application of digital signature? It's very important. Please note. For signing a digital signature, I use my private key. For signing a digital signature, I use my private key. To verify, the others use my public key. So if everything is okay when verifying, it means that this is my message. This is not fake. Okay? You can put different signatures. The result is the same. See this? Okay? And generating private key. Public encryption, decryption, this part. I will send you the program. You can simply run it. You can input different messages. You can encrypt, decrypt, share your public key, not private key, just you can share your public key. Then you can send to each other some encrypted messages. And other using encrypted messages, nobody can see what you are telling to each other. For example, the Telegram group, I will, after you share your public key, I will send some encrypted messages, and just one person can decrypt the person my message, even though all of you, all person in the group will receive the encrypted message, but nobody can decrypt the message. Just one person, the person who has the private key associated with the public key that I used for the encryption. These digits used for authentication. Everybody can find this message. I private for encryption this message. In fact, digital signature is an encryption of a message with my private key. Since others have my public key, will know what is the main message. But what's the application? The application is that this proves that it's me. And it's my digital signature. In contrast to the real signature, as you can see, every time digital signature, I think I talked about this in the previous lecture, but again, real signatures or is same, but digital signatures every time will be changed. Okay, let's in so if you don't have any question, let me back to the no question about this piece of code. Okay. In Bitcoin, we use another encryption decryption algorithm, which is called elliptical curve or EC. Okay. RSA is not used in cryptocurrencies like Bitcoin. Instead, another algorithm called elliptic curve is used. Elliptic curve is something like this. Please try to learn these concepts, and now don't think about the exams, just please concentrate on learning these simple concepts. Okay. As I said, in Bitcoins, another algorithm called elliptic curve is used, and not RSA, but when we want in a cryptocurrency like Bitcoin, when you, for example, Bob wants sends some, if Bob wants to send some Bitcoin to Alice, Bob must have Alice's public key. Okay, public key. So Bob creates a transaction including Alice's public key. In fact, encrypts it with the Alice public key, and who can unlock this transaction? The only person can unlock this transaction is the person that has the private key, and that's Alice. Okay, but in Bitcoin and other cryptocurrencies, we don't use public keys. We use addresses, wallet addresses. What's a wallet address? A wallet address is the hash of a public key. So every person in the, for example, Bitcoin has an address. In fact, the address is equal to, for example, SHA-256 of the public key. Okay. So please note, in all cryptocurrencies, the addresses are the hashes of public keys, and people are using these addresses to send and receive monies from to each other. Okay, and it doesn't matter that we use RSA or elliptic curve algorithm. Even though, as I said, we use elliptic curve, but the general concept is the same for both algorithms. The address is the hashes of public key. Okay, so in next lecture I will talk about elliptic curve algorithm. Elliptic curve. This is another approach for generating public key, private key, encryption, decryption, and creating digital signatures. Also, I will show you the associated libraries in Python for elliptic curve. The commands are very similar to the RSA. There are some differences in the details just, okay? What's elliptic curve? As I said, elliptic curve is something like this. And this is the general equation of the elliptic curve. Y to the power 2 equals to x to the power 3 plus ax plus b. In Bitcoin, the equation which is used is y2 equals x to the power 3 plus 7. How someone use elliptic curve for generating public key, private key? As you saw in the RSA algorithm, someone chooses two large prime numbers PQ, and you know what's the RSA algorithm. But what about elliptic curve? Before talking about how private and public keys are generated in the elliptic curve, we can plus over the points onto this curve. There's an algebra. Let's P and Q be two different points on this curve. Then P plus Q is calculated by this approach. We draw a line, sorry, just let's consider another one. P, Q. For calculating, I'm defining a new operand called plus. I want to show you how to calculate P plus Q. We should draw a line from P to the Q, and suppose it cut the curve in another point like R. If we find the reverse of R here, this is P plus Q. It's an algorithm for encryption decryption. Yes, it's something like RSA, but in a different way. Okay. So as I said, we have an elliptic curve. I'm defining the plus operator. In some books uses dot operator. What's meaning? As I said, P and Q are both 2 points on the curve. To calculate P plus Q or P dot Q, we must draw a line from P to the Q. The third point, the reverse or the third point shows the P plus Q or P dot Q. But if this is P, this is Q, what happened in this case? What is P plus Q? In this case, this line doesn't cut the curve. We define a symbol 0 means infinity. So in this case, P plus Q equals to 0. As you can see, P plus Q is equal to Q plus P or P plus Q plus R equal P plus Q plus P. It means that this operator on the nodes on the curve make a group, an abelian group, okay? But it's not important. The only thing that here is very important is we should know how to calculate P plus Q. Now let me know how to calculate P plus P, or in fact P dot P. Suppose that this is P. Okay. For calculating P dot P, we draw a tangent line. Here is green. This is the x-axis. This is P dot P. So using these approaches, you can find the result of such an operator on two nodes. These two nodes can be different or can be the same. Next week I will talk about details of the elliptic curve. Just here I gave you some explanation about this operator on the elliptic curve. In the next lecture I will talk about elliptic curve cryptographic algorithm. Okay, thank you all. If there's any question you can ask, otherwise next week I will complete this topic. Okay, thank you all. Good night.